Today I wanted to go over scalar triple product because during class I wasn't able to finish talking about this, nor did I really elaborate in another period, so kind of wanted just to make sure that I got everything covered and clearly stated. So scalar triple product is used to help find the volume of a parallelepiped. Now a parallelepiped is a shape that's 3D that is formed by parallelograms. So this can also be referred to, like a special one is a rectangular prism, kind of like a box, but this one just has parallelogram sides. Now it's not saying that it can't have rectangular sides, kind of like maybe these endpoints here, and maybe the top and bottom are rectangles, but that's kind of the gist of it. Okay, so for a parallelepiped, we want to be able to find the volume. Remember, volume is area of the base times height. So the scalar triple product helps us, in a sense, to do this by taking three vectors. So the three vectors are from the three directions or sides of your parallelepiped. So that's where they get A, B, and C. And so you can take the dot product of the cross product of your vectors, or you can take the determinant of your vectors to get the volume. Okay, now volume is going to be a magnitude of this dot product over cross product for the parallelepiped. Notice my signs down here. Okay, now after looking at this further, they are necessary because sometimes we can get a negative determinant or a negative value for our dot product of the scalar or cross product. So then the magnitude actually helps us get to make it a positive value. So you can almost think of it as a absolute value in this sense. So here, if I was to go about finding it, or to maybe explain a little bit more, remember that this is so A, B, C are your vectors. The cross product is the perpendicular one. So that's the magnitude of that is the same as the area of this bottom parallelogram, or the top one, depending on which one you use. And then A stands for the height. So that's where the height and the area comes into play for your volume. So on the next slide, we have three vectors, and I want to find the volume of the parallelepiped given. So now I can do this one of two ways. So first I'm going to show using the determinant. So let's say that the top one's 1 for -7, 2 for -1, and then 1 to 18. Okay, so in this case I can pick any row or column, which makes it nice, which also makes it easy because it doesn't matter how you order your vectors, like the top row, bottom row, middle row, but make sure you don't mix around the the components, because 1 and 4 and -7 really shouldn't be mixed around in that sense. Okay, but you can order the rows however you'd like. We don't want you mixing around numbers so that you get a wrong value, so don't mix them up that much. So let's pick this first column. So I get 1 for the first coefficient times the cross product of these bottom two rows that are left. So I get 4 times 18 minus 2 times -1, and then minus 2 times, now remember it's negative because it's in a negative position in your determinant. So then 4 times 18 again, minus 2 times -7, and then 1 is in a positive position, so it's plus 1 times 4 times negative 1 minus 4 times negative 7. So then here I get 72 plus 2 for the first one minus 2 times 72 plus 14, and then plus 1 times negative 4 minus or plus 28. Okay, so then now putting my stuff together, 1 times whatever is just 1, or is our 74 in fact, so I don't need the 1. Then negative 2 times 86, and then same thing here, I don't need that 1 because it's the same as what I get in the parentheses, so that gives me 24. So now 74 minus 2 times 86, which is 174, or 172, and then plus 24. So that will get me 74 minus 172 plus 24 is negative 74. Now, this is where your magnitude comes in, because I have a negative value and I can't have a negative volume for a figure. The reason why we get negative volumes is because of our vectors' directions are in negative directions or come up as a negative value. So to negate that, that's where the magnitude value comes in. So you're taking the square root of your negative 74 squared, which gets you 5,476, which the square root of that is 74. So it's basically like a absolute value sign there. Now if I did it the other way, using this method, because I have my my vectors, first if I take the cross product of B and C, so that involves I, J, K, so then I have 2, 4, negative 1, and then 1 to 18. Just check to make sure. Okay, so then here I times 4 times 18 minus 2 times negative 1, and then minus j times 2 times 18 minus 1 times negative 1 plus k times 2 times 2 minus 1 times 4. So then I get 72 plus 2 minus j times 36 plus 1 plus k times 4 minus 4. Okay? So here I get 4i, and I get a negative 37j, but then I get 0 here, so I have no k. So then my vector is just 74, negative 37, 0. Either way is the correct way of writing it. Okay, so then next I need to take the dot product of my cross product. So then that gives me, going back up to see what A was again, 1, 4, negative 7. And the dot product of what I just wrote down, 74, negative 37, 0. So then remember, our dot product is each component times its other component, and then you add them all up. So 4 times negative 37 is negative 7 times 0. Okay, so then 74 and 4 times negative 37 gives me 148 plus 0. So 74 minus 148 gives me negative 74, and then that's where our magnitude comes in. So like up there, So then that gets me the positive 74 that I want, just like I had up here. Okay? So then my volume of this parallel pipette would be 74. Okay? Have fun.